Alright, today we're going to take a look at a quadratic function and see how we could use it to figure out the maximum height of a ball. So, you can think back to science class. We know that the height that something travels is related to the time, and it depends on the acceleration and the initial speed that you launch it with. You can see how similar this is to our typical y equals ax squared plus bx. There's no c value because it's basically 0. We're starting on the ground. So if we want to figure out what the maximum height is algebraically, we need to find the vertex of this function by completing the square. Now, we know on Earth that acceleration due to gravity is around negative 9.8 meters per second squared. In math class, we sometimes round that to negative 10 just to make it a little easier to work with. And let's just make our initial speed 15 meters per second. That's how quickly we're throwing the ball out of our hand. So we'll plug our numbers into our function. Negative 10 for a. So when we half it, it's going to become negative 5. And then we're going to have to factor that negative 5 out of our two terms, which leaves us with a 3. And now we think, okay, we need to complete the square, where we take half of 3 and square it. So 1.5 squares is 2.25. But we need to realize that actually it's being multiplied by a negative 5. So to balance the change we just made, we have to do the opposite operation outside the brackets. And now we can factor our perfect square trinomial down. We get 1.5 and 1.5, and outside the brackets we have 11.25. Now we've got our vertex, and we can plot it on our parabola using a handy little graphing calculator called Desmos, and realize that the y-axis is the height and the x-axis is the time. So really what this represents is 1.5 seconds traveling through the air to reach the max height of 11.25 meters. And a lot of this stuff that we know about parabolas and how they relate to gravity, we can attribute to Galileo. His sketchbooks, his early sketchbooks, actually show his analysis of parabolas. So much more on him later.